Hello, welcome to Advanced Geometry's Volume of Pyramid and Cones video. So you should have just watched the demonstration with the water pouring, showing you how a pyramid with the same base is related to, the volume of that is related to the prism. So the volume of a pyramid is pretty straightforward. You are still going to do like a prism. You are still going to do a base area. So capital B is the base area, and then times the height of the pyramid. But as you saw in the video, 3 pyramid volumes will add up to the prism volume. So the volume of a pyramid is, as you probably guessed, 1/3 the base area times the height. And again, capital B is the base area, and then this is your height of the pyramid. So that goes to the center of the base when you have a regular looking pyramid like this. So pyramids contain 3 triangles that are helpful in finding the area and volume, and you can use the Pythagorean theorem for these. So we have used these in a problem before, but what you can see, and if you have highlighters, if you have 3 different colors of highlighters, you could pause and grab those. But the first one here, we're going to use the height and the apothem and the slant height. So there is a right triangle. If you're given 2 of those pieces of information, you can find the third. So again, L for some reason stands for slant height. And that is, again, the height of the triangle, the lateral face. LE stands for what it probably seems that it stands for, which is lateral edge, which is this guy over here. H is the height of the pyramid in the middle. A is the apothem. R is the radius of the base. And then BE is the base edge along the base here, the whole base edge. So this first triangle, we have the height, the apothem, and the slant height. And so height, apothem, slant height would be this one. So you can kind of separate it out if that's helpful to see it a little better. Here's a little sketch as well. Shows it shaded in the middle. Okay, second one we're going to look at is also involving the lateral, or slant height, sorry, and the lateral edge, and then half the base edge. So basically half of the lateral face is also going to be a right triangle. So that's this one right here. And again, in my other picture, I can drag this out and you can see it a little better. So right there, going along half the base edge to the lateral edge is another right triangle that you can use. Okay, the last one involves the radius. So the radius can go out using, again, the pyramid height, and this time the lateral edge is the hypotenuse. So that's this one, the height, the radius, and the lateral edge. And you can see that in my drawing here. If I pull that out along the radius there, it goes to the lateral edge and then again connects with the height of the pyramid. So these are your 3 useful triangles. They're all right triangles. And if you have 2 of those pieces of information, you obviously can find the third with the Pythagorean theorem. Okay, so using that information. So first of all, you need to know how to draw these, and I'll give you an easy way to do that. So a right square pyramid. So to draw it, so first step, drawing it, you want to make the base look 3-dimensional. So a square looking 3-dimensional, you kind of draw it slanted like this, kind of more like a rhombus, and that gives it that 3-dimensional feel. And then to do the pyramid part, what I like to do is just put the vertex, just put a point above, And then you're just going to simply connect those to the vertices of the square. So there's my pyramid. Okay, now labeling, the square-based pyramid has a base edge of 12. So I'll just put a 12 here and a 12 here. And then a lateral edge. So lateral edge, again, is this guy that connects the lateral faces. So that is going to be 10. Okay, now we're going to find the following. So we're going to find the slant height to start with. So I'll do that one in green. So the slant height is here. And again, remember that makes a right angle. So if I have the base edge and the lateral edge and I want to find the slant height, I do want to use half the base edge here. And then I have this right triangle with 10 as the hypotenuse. And then 6, and then here's the slant height. And also draw yourself a separate triangle and label it to see if that helps. So it would look like that. That is a triple, so that is obviously going to be 8. So I have 8 inches. Okay, third step here, find the height of the pyramid. So the height I'll just do in red. It's going to be here and going to the middle of the base, the center of the base. All right, so this one, you actually have some options. You can do a radius and use the 10, or you can use an apothem and use the 8 that we just found. Maybe I'll label the 8 in the picture. So that's 8. Okay, apothems are generally easier for a square. So I'm just going to use the apothem and the slant height. So to figure out that, I would have the height here, and then the apothem. So the apothem of a square is just, again, equal to half the base edge. And then we know that the hypotenuse here is 8. So this one is not a triple, so you're going to have to actually calculate it. So h squared is 64 minus the 36, so that's going to be 28. And so that is equal to square root of 4 times square root of 7, so 2 root 7. So here I get 2 root 7 inches. Okay, lastly, we're going to find the volume. And remember, the volume involves that perpendicular height to the center of the base. So the volume is, as a pyramid, make sure you remember your 1/3. Base area, in this case, is easy. And then 2 root 7 is the height of the pyramid. Okay, so you're going to calculate that. So 12 squared is 144. 1/3 of that is 48. So you get 96 root 7, and that's going to be inches cubed, but that'll go here. So 96 root 7 inches cubed is the unit for volume. Number 2. So a regular triangular pyramid. So these ones are a little harder to draw, but you want to try and draw the triangle. I'm going to dash this too. So draw the triangle so it looks 3D, so something like that. But just remember that's equilateral, a regular triangle. And then again, we just put the point up at the top and connect to the vertices. So here's my triangular based pyramid. And I have a lateral edge of 26. So this is 26. And then I have a height. So the height is going to, again, be in the middle here. So that is 24. Okay, so we've drawn it. Another thing you could get into the habit of doing, which is helpful, is just redrawing the base so that it looks two-dimensional. So maybe I'll do that for this one. It does help a lot. So here's my equilateral triangle. That is the base drawn by itself. Okay, we don't have any information about this base right now, so we're going to start going through and figuring some of these out. Okay, the radius of the base is the first thing you can find. So maybe I'll do that in green because the height connects with that lateral edge and forms this right triangle. So again, the radius would be here. Okay, and that corresponds with that. Now, this is a triple, so there's not much to calculate there, but the radius is it's a 5, 12, 13, so the radius is going to be 10. So this is 10 feet. Okay. 3, the base edge. So now that I know that the radius is 10, so I'll label 10 right here. Now I can help myself figure out the base edge and the apothem, because in an equilateral triangle, if I draw the apothem in there, maybe I'll do that in black. If I draw the apothem here, you do end up with a 30, 60, 90 triangle when it's in an equilateral triangle. So this radius cuts the angle here in half. So this is your 30, and then this would be your 60, and that's your 90. Kind of crammed it in there. So I know the radius is the hypotenuse of that triangle. So that means that my apothem, so I can use the 30, 60, 90 to figure out the apothem, is 5 feet. And then half the base edge here would be 5√3, which means the entire base is going to be 10√3. Okay, and you could maybe label it that here. So that's 10√3. Okay, next thing, slant height is actually quite difficult. Or it's a really terrible number, I should say. So the slant height is going to be, again, on the splitting this lateral face into 2 congruent triangles and makes a right angle at the midpoint. So what we could use for that is the apothem. So the apothem drawn out here is 5, and then the height, which we know is 24, and then that will give us the slant height. So take a minute, do Pythagorean theorem to figure that out. Okay, so you should get root 601. Does that seem right? Yeah. So you get 24 squared plus 5 squared equals L squared. And so that is 576 plus 25 equals L squared. I do not believe anything goes into 601. That's helpful. So the slant height here is root 601, which is a terrible number. Okay, and then lastly, you're going to find the volume. Volume is actually easier than all of this. You do 1/3 base area. So you can do that several ways. 1/2 apothem times perimeter, or 1/2 base times height. I'll do apothem and perimeter. So 1/2 apothem is 5. Perimeter is going to be 30√3. So 1/3 base area, and then the height we said was 24. Okay, so you calculate that out. Maybe pause and try that. But you should end up with 600√3 feet cubed. Okay, last thing. So volume of a cone is very similar to as you saw in the little demo video. You still are going to do 1/3 the base area, but for a cone, the base area is a circle. And then again, times the height. Remember, the height is here, the radius is here, slant height is there. That also creates a right triangle that you can use to help yourself. Okay, last thing here, volume of a cone. So you're going to draw yourself a little oval, put a point at the top. Okay, give this a try. You should end up with a volume of 320 pi feet cubed.